So I'm going to tell about the monitoring of the Baltic Sea health. Somewhere dropped the words by diving, but it's quite obvious that I'm going to talk about diving in this presentation. So, right, just shortly about the speaker. I'm a marine biologist as an education and a scientific diver. I've been exploring the Baltic Sea bottoms for over 20 years now, and at the moment I work as a senior specialist in marine nature conservation in Metsähallitus Parks and Wildlife Finland, and there are some links for our important websites. For example, the itameri.fi is actually a very good site that gathers in all the material that we have mapped from the sea bottom and tells a lot of good information about the Baltic Sea. I also do write a few blogs, kind of for the making marine biology understandable for a ordinary people, let's put it this way, is also one of my aims. So I've been writing a kind of some very easily understandable articles. And I got a little blast from the past moment yesterday in the poster session, looking at one of the scientific diver posters. There's actually me in 2005, a lean and mean diving machine doing a research in an artificial seagrass unit. So kind of got this thought that, Jesus, I've been doing this for a long time. Before you can monitor anything, you need to do a little bit of mapping, so you need to know where you compare all these results you get by monitoring. So we started to fill the map, and every year we did loads and loads of mapping in different methods, and here is the mapping methods graph that which part has been done by diving, by video filming, or by taking samples with different kinds of sampling methods, for example rake. We've been using ROVs, stuff like that, but I would like you to pay attention into this little dark green section of this graph, because it shows how indispensable scientific divers and scientific diving has been in this mapping project. So let's say at least 1/3 of the material we have been mapping or gathering from the seabeds has been done by diving. And as I said, not all of our divers has been qualified scientific divers. We have been doing loads of education by ourselves, so that everybody is doing mapping approximately in the same method and the same way. We have been collecting a VELMU manual, which kind of describes all these methods and how you do it in a VELMU way. And it's been an ongoing project. We have been doing it for 20 years, and at the moment it's actually quite widespread. Even the consultants doing underwater mapping use our VELMU manual book. Just briefly about where all this information that the divers, for example, have been gathering, so the importance of divers in marine conservation. So where the data from VELMU has been used. We use it for in the Metsähallitus Parks and Wildlife Finland. We use it, for example, in the management planning of the conservation areas. We've been using it in assessing the vulnerability of the species and nature types. So every 10th year or so, we have this assessment of the vulnerability. And last time, 2018-19, it was the first time we could also assess underwater species, because we had gathered enough material to know the distributions of quite many species, so we could do this assessment as well as underwater nature types. Here's a little graph about where the biodiversity is hiding. So with VELMU data, add it to the zonation analysis, and you'll get the biodiversity hotspots where you can actually do these EMMA areas. So there are the report that presents all the EMMA areas on our coast, and you'll find it from the pages of the Finnish Environmental Center. So let's hop into the next section about the monitoring dive lines. So there is a marine strategy of Finland, and it's a large plan how to reach a good state of the sea. And there are several actions mentioned in that plan, how to make the sea less eutrophicated and so forth, and to be able to see if there's any effect on these actions, we need monitoring. So what happens regularly in the sea? So Metsähallitus Parks and Wildlife is responsible for monitoring of the 3 habitat types: soft bottoms, which is usually the muddy bottoms, sand bottoms, and gravel seabeds. And we are in the middle of creating a dive line network along the whole coast to monitor the status and changes of this underwater biodiversity. And how do we do this is that we have pre-selected places, because we have loads of VELMU data available. We have selected places from the map that could have a good presentation of these 3 seabed substrates, and then we have done a 100-meter dive line on those places. It's a tape band that we draw on the bottom, and along that dive line we identify the species and the abundances of the vegetation and small macrofauna, approximately every 10 meters. So here's a few nice graphs. How could a dive line look like? There is a side view of a shoreline, and you can estimate the seabed substrates, and then you'll collect the species and abundances. And there's basically the same line running down the hill with the little red marks, if you can see that, on this nice 3D side scan of a reef. And there's a certain species that you'll find in certain depths along the line. And here is a map about what we already achieved. So the idea is to have a 3-year rotation. So the Gulf of Finland, we already did dive lines last year. So we established them. Of course, we'll mark with the GPS and every little detail so that we can find approximately the same spots again after 3 years. Last year we went from Kasnes to Kaskinen. It's a quite a long stretch, and filled it with approximately 55 dive lines. There's yellow dots for sand, black dots for mud, and red dots for gravel sites. And this summer it's planned to continue from the Cork area all the way to the Bothnian Bay. And then the idea is to start this all over again and keep on repeating this every 3rd year. Here's a little example how it looks like in a different seabed substrate types. There's a nice muddy bottom with naiads, and here's a picture of the fractions of seabed substrate types. It's an example dive line that what you've been finding along one dive line. There's a different substrate types: rock, boulders, stones, gravel, sand, silt, and mud. And this is just to show you that usually the muddy bottoms are quite evenly muddy bottoms, so there's plenty of mud when you find one. And then there is from the 21 divings in the most common species found on those muddy bottom dive lines. The same goes with the sand bottoms. It's easy to find bottoms with loads of sand, so they're very representative of its habitat type. But the problem is actually gravel bottoms. They do not exist as you could find 100 meters of gravel bottom. There's a gravel here and gravel there, because it's quite, I don't know why, probably it moves along little gravel pieces, they move with the waves or something, but they're usually quite patchy, and they're more diverse as a bottom types than the two others. So, tracking the changes then, after we have been repeating this, it's time to use some statistics to find the differences. It's possible that we will have to do this for 10 years, 15 years before we start actually getting the changes out that we can really track. But you can use the macrophyte abundance or community composition. They can be useful indicators of aquatic ecological health. And basically the idea is that there are species-specific responses of changes in water quality. So some species, they tolerate more turbidity, more nutrients in the water. And then there are very sensitive species that if the water quality changes into a worse, they will vanish. So those species can be used as an indicators of the state of the seabeds, and there are already made some indicators on the soft bottoms, for example, Hansen-Snickers index, and indicators for sand and gravel habitats. They will be developed in the biodiversity project, which is ongoing at the moment. And there's also different kinds of multivariate methods that you can look for the community structure, but that's more statistics, so I think we'll skip this one. But as a diver, you could also already see what's been happening there, because most of the places where in the archipelago sea were, for example, kind of places where already been like years ago, and you could see already what's happening in there. So Öre, Jostera meadows, eelgrass meadows, you could see that these very thick, large, nice meadows, they have reduced in size, or they're more scarce, there isn't so many shoots growing anymore. Or there's really, really beautiful soft bottom bladderwrack communities in loom in one nice little bay. They're not attached into anything, they're standing in the mud and living happily there. And that was 2016, and when we visited it last year, it has turned into quite a desolate bottom. So I ask you to pay attention into the time scales. So the changes can happen slowly, so along with a long time period, or they can be pretty fast within a few years. You can already see that something's happening here. So for example, I visited the loom Fuku's place in 2018 when it was really, really warm summer, and the seawater was unexceptionally warm, and I could see that there was a destruction going on, and that could be the reason why it's not doing well at the moment. So there are long time changes, there are rapid changes going on in the Baltic Sea, and that's what we try to get grip on with the monitoring guidelines. So now to the part where I'm going to tell a little bit about the voluntary divers. How can the Diving for Science, how the voluntary divers can support the marine conservation. And as we've been already talking yesterday, the professional requirements limit the use of volunteers in our official monitoring work, because everybody needs to know the methodology. We aim to do things exactly the same way, and of course it requires very strong species identification skills. But there are still many things that volunteer divers can do and be useful. So we have been using voluntary divers in Metsähallitus Parks and Wildlife. For example, as Miina just told about the restoration of seagrass meadows, that's the future project. That is planned together with John Nurminen Foundation, and we are actually making a guidebook for seagrass restoration and the guidance for voluntary divers. So we hope to get help on that side. And there's been some eradication of invasive species where the voluntary divers has played a crucial role. For example, in the north, there has been an eradication of Canadian pondweed, which is Elodea canadensis, and that was quite successful project. And then there's a plan in a new biodiversity project that will try to eradicate the Harris mud crab, Liejutascurapu in Finnish, and that's also something that we could use voluntary divers. Collection of marine debris is also something the divers do and can do. And I have been working with a local dive club, Simput, for many years, and they have been supporting Metsähallitus to maintain the underwater nature trails, for example. So there's plenty of things the voluntary divers are doing or will be doing in Metsähallitus. And then me and my colleagues, we actually started to think that what else you could do as a voluntary diver to help the conservation. So we came up with some ideas, which I'm going to present to you here. So divers can actually do observations for an online application like iNaturalist, for example. Choose an easily recognizable species to follow. And if you know a species, so if you learn to know a species, so you can actually see the species in the sea and you can mark them into the online application. And you can even have some kind of species-specific campaigns that, okay, now we're looking for the species of the year, and make a little motivation out of that. For example, large mussels are easy to recognize. One of my favorites is actually the measuring of the lowest growth limits of bladderwrack, Fucus vesiculosus, because every diver, they usually have a depth gauge, and the species is really easy to identify. You can't distinguish it with some other species, and these lowest growth limits of bladderwracks is actually used in the monitoring of the algae communities, the plant communities. So if the water gets more turbid, more murky, this species needs light, so actually the lowest growth limit will start rising. And then you can see that, okay, something's happening here again, and this would be a good way of the divers to do observations, because they would really complement the official monitoring of hard bottom habitats. And of course you can do observing of drift algae mats on the seabed, so more nutrients, more drift algae mats. That's a bit boring to me, but it's very important to follow that. It's one indicator of eutrophication. And then we started to think that many divers actually visit the same wrecks all over again. Why can't there be, for example, some kind of a fixed monitoring squares on a shipwrecks, so we could get the information on the deep sea organisms that are attached to the wrecks? I don't know if this is already done with the museum wrecks or something, but this would be a very useful information, because we don't usually do deep dives in our monitoring work. There is actually a lack of observation of non-commercial fish species, and that would be also a good voluntary observations to make. So learn some fish species and make observations on them. And of course, the looking for the invasive species, those you can already sign into the vieraslajit.fi, and they are really fast to spread, so it's really important to get information about their distributions, and that's where the divers could be very useful. So here at the very end, I'm going to show you a little teaser here when the diving season is about to begin. So this is from the Stora Hästö Underwater Nature Trail, and here are some volunteer divers from the Simpu club that has been cleaning and maintaining the trail. please note that the voluntary divers has much better balance that I would never have. So there you go. Thank you.